Good afternoon, everybody. How are you all? This is Dr. Nandi. Today, I will introduce you to a problem in regression. So, without further ado, I will share my computer screen with you. The average gestation age from a conception to birth of a newborn infant is about 40 weeks. The following table presents the gestation age in weeks and the corresponding birth weights in pounds for infants. So we have a row of data for gestational age, another row of data for birth weight. Find the least square regression line equation for predicting birth weight from gestation age. Okay, so we are going to predict birth weight from gestational age. So we are going to, part A. So birth weight we are going to predict. So birth weight will be Y and gestational age will be X. Age is X. So Y is the dependent variable. And X is the independent variable. Okay. So I'm going to use TI-84 calculator. I will enter X data in L1 and Y data in L2. So the first step is to clear memories in the calculator in TI-84. What is the step for that? Second button, then plus button, then scroll down to number 4 and enter. You will get clear all list on your calculator. And again enter and done. That means you have cleared the memories of the calculator. Okay, so let's do that step. On button, second button, plus button on top of the enter button on the bottom right. Then number 4, clear all list on the calculator screen, again enter, and that will say done. Okay, now how do I enter the data? So next step is I press the stat button and then number 1, which is edit, and enter data. Okay, so stat button, number 1, enter data. So in L1, I'm using the gestational age, which is independent variable. Enter data is X data in L1 and Y data in L2. So my X data is gestational age 36, 37, 38, then 39, then 40, then 41, then 42, and 43. After I enter the last number in L1, now last data point in X1, I press the right cursor key on the top right corner of the calculator to move the cursor to the first line in L2. Then I enter the data, Y data 6.1, 6.6, 7, 7.4, 7.7, 7.9, 8, and 8.1. Okay, so I don't know what is this. Okay, so we got the data in L1 and L2. Okay, so we have to find first the least square regression equation. So for that, we press the stat button after entering the data, and then highlight calc on the top row, then select number 4. So stat button, then calc, then number 4. So I'll create some space here. Okay. So my next screen is linear lin reg ax plus b. Okay. So my x list should be L1. My y list should be L2. Make sure the Y list is L2. If it is not L2, then bring the cursor after the colon in Y list second line and press second and 2. So L2 is obtained by pressing the second key followed by 2. That will give you L2. And then you scroll down directly to calculate. Okay. Nothing in other lines. Okay. Directly to calculate and hit enter. Okay. Put the cursor on calculate and hit enter. Okay. So the equation of the these are predicted birth weight. Predicted birth weight is equal to, my slope is 0.286, you might say, x, and my y-axis intercept, that is where the fitted line cuts the y-axis, is 3.936, negative 3.96. So this is my least square regression line equation. Square regression line equation. Line equation for predicting birth weight, which is y prime from gestational age, okay, from x, which is gestational age, how long the womb is, the fetus is in the womb, the gestational age, okay. So that is the least square regression line equation. Now I will calculate the correlation coefficient and the coefficient of determination. These are already available to me in the calculator in the same screen that I use now. So part B, okay. Was it part B? Let me take a look quickly. Yeah, part B. Then make a residual plot. Okay. So part B. If I look at the screen, my R square, which is the coefficient of determination, and determination is equal to, only for R square, I will multiply it by 100%. So 937, multiply that by 100%. So if I multiply by 100%, the decimal shifts 2 places to the right. So 93.7% of the variation in Y, that is birth weight, can be explained from the least square regression line. From the least square regression line. Least square relationship between X and Y. Between X and Y. Okay. That's coefficient of determination. How about the correlation coefficient? R is the correlation coefficient. And that is equal to 0.967, which this indicates a strong linear relationship, a strong positive linear relationship between X and Y. Relationship between X and Y. Okay. X and Y. Okay. So let me move this a little bit up. Part D asks for a residual plot. So we will do a residual plot. Part C, okay, part C, residual plot. Residual plot. So let me erase this and do it correctly. So residual plot. So first of all, what is residual? Okay, for any X, for any value of the independent variable X, is Y observed minus Y hat. That is observed value of Y minus predicted value of Y. Value of Y. Okay. And what is a residual plot? So this is a residual plot. You have X on the horizontal axis and residual values on the vertical axis. That's your residual plot. The key thing to note, do not want to find a particular pattern in residual plot. Okay, so we have to wait. So my tip is, even if you calculate R square and it looks great, you still should do a residual plot to determine if there is a pattern in the residual plot. So how to do the residual plot is the next question. So let me move this a little bit. So I'm using the TI-84 calculator as I mentioned before. So in TI-84 calculator, press the stat button and 1 button. Stat button and then 1, number 1. Okay. Which is edit. Okay. And then move the cursor. Move the cursor to the first line in L3. In L3 by using right cursor key. By using right cursor key. Okay. Then use the up cursor key. Up cursor key. That is this key. To move the cursor to where L3 is written. L3 is written. Is written. Okay, so we are using the up cursor to move where L3 is written. Okay, next step. Okay. Next step is press the second button. Press the second button with the cursor in L3. Second button, then stat key. Second button, then stat key, which is in the second row of the calculator, then number 7. Okay. And at the bottom left corner of your calculator, you will see this is in the left corner. Left corner. You will see L3 is equal to L recede, means list of recede. Okay. List of recede. Recede is the small form of residual. L3 recede. Okay. Once you see that, then you hit enter. Okay. And hit enter after that. Okay. After you see L3 is equal to list of recede. Okay. And the bottom left corner. This will be bottom left corner. Okay. Bottom left corner. So hit enter. L3 is now filled with residual values. With residual values for all x. Again, remember residual is for each x, it's y observed, that is the actual value of y, minus y predicted, okay, from the least square regression. Now we have to make the residual plot, okay. So what do? I press second button and then y equal to key on the top of second button, y equal to key. Second button and y equal to key. Then number 1. Okay. And hit enter. Okay. So I'm on plot 1. Number 1 key, I'm on plot 1. Okay. First line should be flashing on. The cursor should be on. Second line type, it should be type of chart. First type of chart. This is the first type of chart. Okay. And hit enter. Okay. Bring the cursor on the first type of chart and hit enter. So that the cursor in the second line is flashing on the first type of chart, which is a scatter plot. Scatter plot. Scatter plot. Okay. That means X and Y data points are scattered all over. Okay. Now X list, the next line is already set at L1. Y list we have to change. In the Y, I'm going to plot the recede or residual, which is in L3. So I have to make it L3. So bring the cursor on the right of the colon in Y list and then type second button and then 3 button. That will make it L3. So second button and 3 button. Okay, that will make it L3. Now we will make the plot. So how do I make the plot? Now press the zoom button, which is in the top row, extreme top row, third key. Zoom and then number 9. Press number 9. Zoom button, third key in the extreme top row, and then number 9. And you will see a residual plot. So the residual plot shows a pattern. How do you know so? Look at the residual plot. So this is your x-axis, and your residual pattern is like this. If you join, it's an inverted U. We see a pattern. We see, or write it down. We find a distinct pattern. Find a distinct pattern in the residual plot. Okay, so if I move this a little bit more, and let me change the color of the plane, a distinct pattern, a distinct pattern in residual plot indicates that the linear regression model between X and Y is not good, is not appropriate, you might say. Is not appropriate. Okay, and you want to check that out, why it is not appropriate, is not accurate. So here is my another tip. We will make a plot of X versus Y. Let's see what we get. So again, we press second Y equal to, there's the second button, then the Y equal to button on top of it, then number 1, okay, and type, first line should be on, second line type, leave it on the scatter plot number 1, okay, and then X list is L1, change the Y list back to L2 because the Y data is in L2. So bring the cursor to the right of the Y list and press the second button. How do I make it L2? Second button and 2. Second and 2. Second and 2. It will change to L2. Okay. Now I will create some space and we will press zoom 9. So after doing changing Y list to L2, press zoom button, which is the third key in the extreme top row, zoom number 9. Zoom number 9. And you will see the reason why the linear plot is not a good fit. You are seeing something like this. Up to a point, it's linear, and then it kind of curves and flattens out. So it is not a perfect straight line fit. So, therefore, the residual plot tells us that there is a pattern in the residual plot, that the linear regression model between X and Y is not appropriate. And we verified that by making a plot between Y and X. So if we now go back to the original question in part D, they had asked true or false if the coefficient of determination, that is r square, is large. Remember, our r square is large. There must be a linear relationship between x and y. The answer is no. So answer to part D. So part D. Part D. Even if even if r square is large, coefficient of determination is large, this does not necessarily mean there is a linear relationship, is a linear relationship between x and y, and between x and y. So my last tip of the day is that you are going to check after fitting the best fit line or after fitting the least square regression line, do a regression plot to make sure there is no pattern in the residual plot. If there is a pattern in the residual plot, then the best square or least square regression line or the best fit line is not appropriate, as in this case, even though r square or coefficient of determination is large. So I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. If you like this video, please share with your friend. Maybe your friend will also like it, and you and your friends. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner. You know I come back every time with a new problem in math and a new solution. Thanks for watching. Thanks for supporting me, and rest assured I'll be back next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time. Thank you.